We're going to talk about operations on functions as we move into chapter 5. So we're looking at combining multiple functions together and using them to solve problems. So you're going to see that we're going to need to add multiple functions together. So you can see here as an example, if I need to take f of x and add that to g of x, the notation for this would be f plus g of the variable x. So separately, you'll take f of x plus g of x and then add those two separate functions together and combining all of your like terms, leaving you with 6x minus 5. If you have to subtract functions, so notice that they're using the same named functions, f of x and g of x, but the notation for that would be f minus g, that's the named function, of x. That simply means to take our f of x minus our g of x. Now when we do that, we want to remember that we have to subtract the entire function. If there's more than one term here, you would have to distribute that negative sign. So that gives us f of x minus g of x is 4x minus 5 minus 2x. When we combine our like terms, our subtracted functions give us 2x minus 5. We can also multiply and divide those functions. So if I take f of x times g of x, I simply multiply those two functions together. But when I do that, I'll have to distribute that 2 of x inside of that parenthesis grouping to give me 8x squared minus 10x. With a division of functions, I need to remember one thing, that you are never allowed to divide by 0. So we always want to notate what would put 0 in our denominator to show us that that won't exist in our function. But when we simply look at taking f divided by g, so I'm using the named function f of x and I'm going to divide the g of x function, that gives me 4x minus 5 divided by 2x. Now here I would want to notate that x would not allow to be 0, because if I plug a 0 in for x, that would place a 0 in my denominator, which is not allowed. There's no way we could ever divide by 0. So my second screen just kind of goes through that notation. So when you see f plus g, these f and g's don't go into the actual operations. It's just telling you which named function to use. So that means that you're adding f of x to g of x. You're subtracting f of x minus g of x. You're multiplying f of x times g of x. And the last one would be division, f of x divided by g of x, where nowhere in the denominator are you allowed to equal 0, so you would notate that the bottom function cannot give you 0 and notate exactly where it would. Okay, so let's look at some problems here. So I'm giving you two functions. F of x is given to be 3x squared plus 7x. G of x is given to be 2x squared minus x minus 1, and I'm asking you to add the two functions together. So I'm asking you to take f of x and add it to g of x. So that's going to give us 3x squared plus 7x plus 2x squared minus x minus 1. So once I place it in that notation, f plus g of x, again, we're not placing the f of x's and the g of x's in there, just their functions. So now I'll collect my like terms. So I have in total 5x squareds. 7x minus x gives me a total of 6x's with a constant of negative 1. So f plus g of x simplified gives me 5x squared plus 6x minus 1. Let's look at if we subtract those two functions. So I'll have to take f of x minus g of x this time. Now this is one that I'm going to have to make sure I remember to distribute my negative. because my f of x function is 3x squared plus 7x, but I need to subtract the entire g of x function. In doing so, that's going to give me a negative 2x squared, a positive x, and a positive 1. And then I will go ahead and collect my like terms. So when I simplify f minus g of x, I end up with 1x squared. I end up with 8 x's and a constant of 1. F minus g of x gives me x squared plus 8x plus 1. All right, so let's look at two different functions this time. So this time my f of x is 3x squared minus 2x plus 1, and my g of x function is simply x minus 4. This time I'm asking you to find the multiplication of the two functions. Find f times g of x. So that is take f of x times g of x. Now when I do that, that gives me 3x squared minus 2x plus 1 times the quantity of x minus 4. So I have some distribution to do. I'm going to go ahead and distribute that 3x squared first. That's going to give me 3x cubed minus 12x squared. And then I'll distribute the negative 2 of x. That's going to give me negative 2x squared, and that will give me plus 8x, and then I'll distribute the 1, plus x minus 4. So now, as I distributed, I went ahead and organized my like terms. So I have 3x cubed minus 14x squared plus 9x minus 4. And that gives me my f times g of x function. 3x cubed minus 14x squared plus 9x minus 4. Now we're going to use those same two functions once again, and we're going to do division. So I'm asking you to take f of x and divide the g of x function. So I have 3x squared minus 2x plus 1, and I'll have to divide this by x minus 4. Now I could see if this will factor for me, but I'm looking at my two factors. It doesn't seem that I can factor that in such a way that I would be able to divide that x minus 4 out. So I'm going to leave it notated as division, but I want to remember that no matter what, the g of x is not allowed to equal 0. So what I do here is I'm going to take my denominator and set it equal to 0 and solve to see where it would equal 0. What looks like that my g of x would equal 0 at 4. So if I plugged a 4 in right here for x, that would give me 4 minus 4, which is 0. Well, that's not allowed in this function, so I'm going to notate where x is not allowed to equal 4. So this would be the division of functions of f of x divided by g of x, notating that my denominator is not allowed to be 0. So I'll notate that x would not be part of my domain, so x is not allowed to equal 4. All right, now, what if I ask that you take negative f plus 3g of 4? Okay, so what does all of that mean? Remember that f and g is simply naming the function, so it's telling you which functions to use. So my first order of business would be to take negative times the entire f of x function. So I'm going to negate that first. So I'll take negative times 3x squared plus 7x. Technically, that's a negative 1. Then I'm going to add that to 3 times the g function. So the g function is 2x squared minus x minus 1. So I'll take 3 times 2x squared minus x minus 1. So I negated the f function, and I took 3 times the g function. Now I'm going to simplify that, and then I'll handle that 4. It's actually not times 4. It's replacing the x with the 4 with substitution. So let's simplify what I have so far. I have negative 3x squared minus 7x plus 6x squared minus 3x minus 3. So I distributed my negative 1 and I distributed my 3. I'm going to go ahead and collect like terms now. So that's going to give me 3x squared minus 10x minus 3. Now what I'm going to do is I'm going to replace all of my x's with 4. So anywhere I see an x, I'm going to replace that value with 4. So I'm going to take 3 times 4 squared minus 10 times 4 minus 3. And when I calculate that out, that simply will give me 5. So remember, when I'm looking for a function of a constant, I'm going to get a constant in return. All right, so my last one, I'm asking you to take f times g of negative 2. So the first thing I'm going to do is I'm going to multiply these two together. So I'll take 3x squared plus 7x and multiply that times g of x, which is 2x squared minus x minus 1. So I'll do a quick distribution. So that gives me 6x to the 4th minus 3x cubed minus 3x squared. Then I have 7x times 2x squared gives me 14x cubed minus 7x squared minus 7x. So when I simplify this out, I have 6x to the 4th plus 11x cubed minus 10x squared minus 7x. And the last thing I'm going to do is deal with this negative 2. So I'm going to replace my x's with negative 2. So I'll make this 6 times negative 2 to the 4th power plus 11 times negative 2 cubed minus 10 times negative 2 squared minus 7 times negative 2. And when I calculate that out on my calculator, I will get a negative 18. Okay, so let's look at putting all of this together. So it says Amelia is buying tickets to an aquarium for a school trip. Adult tickets cost $24 and students tickets cost $15 each. There will be 3 adult chaperones on the trip. So they first want us to write a function that represents the total cost of the tickets, where x represents the number of students. So since we know that there were 3 adult chaperones going, I'm going to quickly do that math. So 3 adult chaperones at $24 each means that the chaperones are going to cost us $72. That's the cost of the chaperones. So I don't need to put those into the equation as a variable. So I'm going to write my c of x function. The cost of going on the trip is going to cost $15 for every student. In addition, we know that there are 3 adults going, so it's going to also cost us an additional $72. So c of x, where x represents the number of students, is 15 times x plus 72. Now it asks us to create a different function. It says everyone that goes on the trip will split the cost evenly. Write a function n of x to represent the number of people who will contribute. Well, n of x, the number of people that are going on the trip, is the number of students, which we do not know yet. That's x, that's our variable, that could change. Plus we know there will be 3 adults. So now we know a function that represents the cost. And now we have a function that represents the total number of people going. Okay, so it's 2 separate functions. Now, let's find a function for the total cost that each person will pay. So if they're going to split the cost, we're going to take the cost and divide it by the number of people going. So we're going to take both of those functions and divide them. So the cost function, you'll recall, was 15x plus 72. The number of people going was the number of students plus 3 adults. So this gives us the division of 2 different functions. Now, if 20 students go on the trip, how much will it cost per person? So what we are looking for is to take the cost divided by the number of people going, and then we're going to input 20 for our x. So that gives us 15 times 20 plus 72 divided by 20 plus 3. And when I calculate this, on top I get 372. On the bottom I get 23 total people, which is about, when I round this, $16.17 each, since everybody's going to be splitting the total cost. All right, so I'm going to give you some practice for these types of problems where you are taking operations of addition, subtraction, multiplication, and division and put them on Google Classroom. I hope you all have a great day.